Okay, all right, before the break, we did a lot of work. Did a lot of work. Right, I've updated our so far list. So the last thing we did was edit a contact, and our controllers are starting to get really messy. Contact list servlet is still nice and clean. It only has one do-get, and that do-get only does one thing. And that's what we like, right? Like, a method should probably only do one thing. And that's how we're gonna hope to keep it. But for now this is what we've got. These are the views that we have so far. The only thing that we have left to do is going to be a really easy task, which is to delete contacts. And I would actually be inclined to skip this, but I wanna write it just to make sure that our delete code in our repository that we created. I want to make sure our delete code actually works because we wrote it and we haven't tested it yet. So just quick assignment. This is going to be an assignment to delete contact. How do you suppose this one ought to work?
So alongside the listing, do you want to have an option for delete?
Oh, like in the list of all contacts?
Or your contacts actual page. Or maybe in view.
Yeah. So you guys have like this actually gets us thinking about other user interfaces that we've seen, right? For me, my mental model is my iPhone. I've been sort of basing this off of like what things that. So in my iPhone, I can see a list of contact names. Then if I want information, I can click on the contact, and that'll see all the information. And then if I want to delete the contact, I do that from its edit page. Yeah. So we don't have to do it on the edit page. Maybe we can just do it from the view page. Doesn't matter too much. The point is, what's the point? What was the point?
Just need the contact ID.
The point is we just need the contact ID, and we need it to be in a post, right? We probably want it to be in a post.
So you could basically have one button called edit and another called delete, right? On the same page, in the same view.
In the same view, they would have to be different forms.
Yeah.
Well,
you could have two actions associated with.
I think you can only have.
One action.
Yeah, my HTML is not actually all that good, but I think you can only have one action per form. Is that true? Yeah. Yeah. So we actually need to have a form for deleting. That form isn't going to have any fields. It'll just have one hidden ID field.
Why do we need a post? Why did you say that? We need a post.
Oh, good question. This again gets back to sort of RESTful design a little bit. I mean, ideally, it wouldn't be a post. It would be a delete. It would be an HTTP delete. But you can't submit delete requests from HTML. Only from Ajax or from JavaScript. So we could do it that way too, if we want to write some JavaScript in our views.
Why can't we do it in get?
Because we want GET requests to be safe. GET requests should always be just immutable, right? They shouldn't change. Yeah, idempotent and yeah. So they shouldn't change any state on the server. Yeah. We could do it with JavaScript. I mean, that might be fun. This isn't a JavaScript course, but whatever. So I'll say that do post should have yet another case if delete right. You delete a contact and then you go back to the contact list this time, right? So that's going to be our work. And then probably just the only place that we need to make any HTML changes is probably just in the view contact page or the edit contact page. Either one. Either one is fine. So I'll do it in my example. I'll do it in the edit page. So this should be a quick one. I'll give you guys like 5 or 10 minutes, and then we'll move on to Hibernate, which of course is the point. Yeah, so let's get this recorded. So what are some HTTP methods? Give get, post, put, yeah, delete, head, options.
Trace. Trace.
That exists. Right. Okay, so a bunch of informative and useful sounding HTTP methods. I really like get, post, put, and delete because those are your CRUD operations basically. Okay, cool. Now in HTML, if you have a form, what HTTP methods does an HTML form support?
What, HTTP?
Yeah, which HTTP methods does a form support?
Post.
Post and
Get and post.
get. Yeah, get and post are the only ones. You can't put from a form. You can't delete from a form. Patch is another one, right? You can't patch from a form. Yeah. So that kind of sucks. The only way to do it, so you can do it using AJAX, or your XML HTTP request objects in JavaScript. However you want to do that. The only way that I know how to do it is using jQuery because I'm lame. But yeah, so we'd like to just what we would ideally do in contact servlet is we'd have a do delete method, right? Do get, do post, do delete, right? Because the thing that we're doing is deleting. But sadly, we can't actually submit a delete request. So the next best thing is to submit a post instead. Yeah. You guys have had probably enough time to work on this. So let's just go ahead and do it. Go back to my Spring. Okay, we're in contact servlet. Okay, so we've got yet another one of these else if blocks, right? Oops. Else if request.get parameter is delete, then what do we need?
Contact repository.
Yeah, so we need the ID. We I guess need the contact.
Still the address ID.
No, you can.
Well, so it's an interesting question. What's the relationship right now between addresses and contacts? Yeah, it's an identity relationship. It's one-to-one. An address is actually one-to-one with a contact. So if we delete a contact and we don't delete the corresponding address, we basically have garbage in our database.
Why do you act as one-to-one?
Um,
We are not specifying it
Exactly, yeah, we're not specifying it anywhere. We haven't specified that there's a one-to-one relationship
But
between.
the schema has a contact, right?
But the logic, yeah. So here, let's just put this in our list of gripes, I guess.
At least for our testing code, we have an address without a contact.
Mm. Yeah, I mean, maybe, right? Maybe there's a one-to-one relationship. Maybe not. We don't know. Right now, I think that the logic in our code is basically that there's a one-to-one relationship between a contact and an address. So yeah, so probably we need to do the same thing. We need to look up the contact and look up the address, and then delete both of them from their respective repositories. Right.
Better way would have been to set this up in the database, right? The application there, you don't have to worry about it.
Yeah. Right. If we had been, well, so let's take a step back for a second and just observe how simple is our schema. We have a very simple database schema, right? And our database schema, I think, is actually pretty much correct. I think there might be some additional constraints that we could have in the schema, but I mean the schema itself is basically correct. The thing that's weak right now is our repositories. Right, our repositories are dumb because they don't know the relationship between these things, and our entities are also sort of weak too, right? Our contact has an address ID, but it's not actually like if I load a contact, it's not doing a join to load the corresponding address, right? So this is all totally weak sauce, right? So that's stuff that we're going to hope to address. For now, for now we're dealing with these entities as though they were unrelated, right? So we'd have to say contact repository dot delete contact and address repository dot delete address, right? And we need to, hey, all right. I'd like to be able to type here, but this window keeps popping up. Go away. All right. Yes, redirect, and this time we'll just redirect to the contact list. Oops. Yep. All right, so that's my handler logic, and then I'm just going to put this in the edit contact page. It doesn't really matter where you want to put it. All right, so I'll just have a quick form action equals contact method equals post, right?
You can have two forms in the view.
Mm-hmm. Yeah, you can. I mean, yeah, this is just HTML. You can have as many forms in a page as you want, but each form can only do one thing, right? And this is why HTML forms suck, right? It's like people generally just use JavaScript to do all this stuff now. It's because the form model is too inflexible. Input or yeah. All right, so maybe that works. Am I missing anything? I think I'm all right. All right, my pile. I was picturing the Stack Overflow where I submitted my dog into the database a million times. I was picturing my dog stacked onto just standing on his own back. It's turtles all the way down. It's Teslas all the way down or something. All right, edit contact, and well, that's a little bit ugly, but I don't care. All right, delete. Hey, okay. All right, so that seems to have worked, and let's just also verify. Oops, verify in our database log. Yeah, so we've got. Here we go. Yeah, so we insert an address, we insert a contact, and then we delete the contact and delete the address. Yeah. All right. Good enough.
One question.
Mm-hmm.
So in the pain points you mentioned that basically, providing the relationship between entities, you mentioned it as a pain point, the list of issues or whatever.
Yeah. I mean, we're not able to really.
You could do that.
Mm-hmm. Yeah. Right. Here in our code, the relationship between these different entities is implicit, meaning we can screw it up. Right. Anything that's implicit, that's just sort of inherent in our code logic, is something we can have bugs in. Right. I could very easily have forgotten to delete the address, or I guess the foreign key constraint would make sure that I couldn't have. Yeah. So it's not possible.
The database to,
Yeah. So it's not possible to have a contact without an address, but it is possible to have an address that's not referenced by any contacts, and so that's not that good. So when we start seeing Hibernate, we'll actually see these relationships become explicit, and Hibernate will be able to manage the life cycle of all of these things. Okay. Any I mean, this was a simple little bit of code, right? No questions here. Great. Let's commit this. All right. So enough of this crap, right? We've done about all that we want to do here, right? And this is a fair amount of code, right? In the course of about a day, we've written, a substantial chunk of code, right? We have this address and contact and address, these repositories and a bunch of servlets. We've got our setup, right? We had to write a fair amount of code to support all this. This was a substantial amount of work. And sort of the sad part is that it's not a substantial amount of functionality, right? We'd want a little bit more bang for our buck. We want each line of code that we write to do something, right? Okay. So here, let me close this stuff out for a moment.
So
and
with
let's.
the Hibernate, are we going to delete stuff from here and?
Yes, absolutely.
So if you want to have a snapshot of this, you just need to make a separate copy of it.
If you want a snapshot of this, the good news is we've been using Git, right? So you can always go back and look at previous iterations. Another thing that you can do if you want is create a branch in your local repository. You can create a branch from here, or create a tag or whatever, right? I mean, this is all just basic version control stuff, right?
How do you create a tag?
That's a good question. I think it's just git tag.
And then so did you upload this stuff?
Yes. Yeah. This is all uploaded. All right. So let's talk about our pain. This will be a little mini therapy session here. And let's try to categorize, because we actually have quite a few of these JDBC related pain points. So let's try to categorize these somewhat. let's categorize these into, let's see, I don't know. I don't even know how to categorize these yet. So let's try to just pull related things together and see how they form. All right, everybody. Yeah. Oh God, it's time to stand up, isn't it? Help me out. What things are related to one another? Here, let's. Code maintenance issues. Right. Right. It's not good enough to just write the code once and then and then ship it. Right. Once we've done it, then we're responsible for it forever. That's called job security. So we've got these code maintenance issues, like this one, right? Our entities can get out of sync with our SQL. This is another one. These lack of explicit relationships, right? We can easily have bugs by not understanding the relationships between the entities in our system, right? We only have 2 entities in our system. Yeah, and already it's like, oh, which things should we delete when? That shouldn't. If we're starting to see hints of difficulty at this point, then obviously it's not going to scale, right? Let's see, flexibility, I guess, or well, this is actually sort of 2 separate issues. Right, our code is tied to a specific SQL implementation. I guess the one must know SQL is also sort of a job security related issue, right? Right. I don't want to ideally if I'm programming in Java, I should know Java, not several other languages. All right. General ugliness, I guess, and boilerplate, right? Because we have a lot of that. Right. Joins and transactions. Yeah. So we have performance and correct. So sort of performance and correctness kind of issues. No transactions, no joins, and what else? I guess this. Right. All this kind of stuff. Yeah. So that's, I don't know. Does that seem like a reasonable categorization? I told you guys to help me out. You didn't help me out one bit. I had to do this all myself.
I nodded.
Yeah. So I got moral support from the front row. All right. Right. So this right here, this sort of laundry list that we're looking at, should give us sort of a set of criteria of if we were going to design a better system, if we were going to design something that we would hypothetically call Hibernate, what would we want it to do for us, right? So let's talk about these one by one, right? Because this, basically what I'm introducing here is the idea of an ORM. What's an ORM?
Object
Mapping.
Object relational mapper, yeah, object relational mapping, or yeah. Right, so this is now our requirements document for what we want from an object relational mapper. Object relational, so we've got objects on one hand, right? These addresses and contacts, these domain objects that's our business logic. Those are something we know how to reason about in our little object-oriented world. Then we've got our database world over here, which is a totally different paradigm. Our relational database. So what we want from an object relational mapper is we want solutions to these problems, right? So entity and SQL can get out of sync. So then what do we, how do we turn that into a requirement? What do we expect that the RM is going to do for us?
So as you make changes in entities, it would sort of make changes in terms of database schema?
Yeah. So our objects are actually going to determine the database schema. Right? So we shouldn't have to initialize the database schema ourselves with this setup thing that we made. And we shouldn't have to figure out how to write these queries and stuff, right? Like the object structure should dictate that. Okay, I guess that also sort of deals with the one must know SQL problem, right? Because maybe if the objects are determining all this stuff, then, well, just get objects from somewhere. We should just be able to get objects, right? We shouldn't have to worry about the language that we use to query.
Is it then also true for storing objects?
Yeah, get objects from somewhere, put objects, right? Yeah. So we want to make some sort of an abstraction, right? This idea of an ORM is sort of an abstraction. It's not a perfect abstraction. There are still times when we need to worry about queries. There are still times when we need to worry about the relationship between tables and stuff like that. So it's what sort of opponents of this refer to as a leaky abstraction. Which, I mean, it is. I agree. It's not a perfect abstraction. It has its issues, and we'll see some of those issues probably starting maybe tomorrow, later today, or maybe tomorrow. Right. But at least at a first cut, it's going to solve our most basic problems in a very elegant way. Right. Just deal with objects. Forget SQL. Right. This issue of no explicit relationship between entities, it should also deal with that too, right? When we went and deleted a contact, we had to know that we should also delete the corresponding address. We had to know that. Well, how do we know that? We shouldn't have to know that. So system must know relationships and constraints. Right, so that's a big requirement for us. I want to be able to say that a contact has a one-to-one relationship with an address, so that if I delete a contact, the address should just be deleted. Right?
Should be done through the code rather than the database referential integrity.
It should.
Or it shouldn't matter.
I shouldn't even be able to tell the difference. It should just happen.
But if required, would you want to have flexibility to specify that?
It depends. We'll see when we get into more more specifics, right? Okay, this one actually sort of falls out of all of these as well, right? If we don't deal with SQL at all, then this problem is just solved, right? Okay. Where was all the try finallys?
SQL.
It was in our repository implementations, right? Right, because the connection is a resource, a statement. Thank you. You see, a statement is a resource, a result set is a resource, right? So we probably forget JDBC. I think is the general requirement, right? Okay. Checked SQL exceptions everywhere. I mean, we've seen that, right? In our repository, we said, okay, well, SQL exceptions are somebody else's problem. But in our controllers, they become our problem again. So once again, SQL exception is a JDBC thing, so probably the answer to that is forget JDBC, right? And then marshalling and unmarshalling. This also actually sort of falls out of this one, right? Right. This probably the biggest thing in an ORM, ignoring all of this stuff about relationships and constraints and all this stuff, and repetitiveness of code. I mean, let's say our ORM didn't do anything else. At least the one thing that it should do is be able to get objects out of a database and put objects in a database. That's requirement number one, right? So that's really the biggest deal. Then this stuff, we'll talk about this a little bit. Joins is probably the first thing that we'll see, right? If we get a contact, we probably want to get its address too. Maybe not. But our current model, we don't have a way of expressing that. Transactions, we're not really going to solve the transactions problem yet.
So for joins, do we care about like inner left join and those kind of things in the ORM, or we're not supposed to?
We're not supposed to. It should just be taken care of. And in fact, the real question is like, sometimes, if I, in my contact list, for example, I don't need all of the addresses. I don't need any addresses, so I don't want to do the join. Maybe, right? So the question is, what's a good policy? How should it figure it out? And then another, this was sort of a little bit of sugar here, but this create table if not exists, well, yeah. So Hibernate will take care of that for us. That wouldn't have been the highest requirement on my list, but it's definitely nice to have, right? All right. So these are the sort of things that we expect from an ORM. Okay. Any questions on just kind of like the general idea of what an ORM is, what it's for? Okay. Cool. So let's go back then to our code, and I'll show you some stuff that I added for you. So do me a favor, look at this with me in your own. Make sure that you all have this. This is why I want you to look at this with me. Make sure that in your source code, in your copy of the Git repository or whatever, you have a copy of this persistence.xml. If you have that, and you have, there's also a change that we needed to make in web.xml and in the Maven XML or the Maven POM. So make sure that you have those. Okay. Give me a shout if you don't. All right. So first things first, I always start from the POM. I added a couple other dependencies, right? Okay. First of all, you'll notice that I didn't, this is kind of important, I didn't add any additional compile dependencies. The Java EE API provides all that we need in terms of what we're going to link against. All of our JPA annotations, right, our Java persistence annotations, come from the Java EE API. Hibernate, you can use Hibernate as Hibernate. It has its own specific API. But you can also use Hibernate the way that we're going to do it, which is just as a provider for the JPA.
That's what provided means?
No, provided means something else. Provided means that, well, actually, yes, sort of. Provided in this case means that some other jar is going to be providing the implementation of these things, or some other collection of jars. So in that case, it'll be Jetty is providing the implementation of most of it, as well as, in this case, Hibernate. So Hibernate is providing all of our JPA implementation. So I've added two dependencies here under Jetty, right? So this is all container managed again. This is what we talked about yesterday. Hibernate is being managed by the container.
One thing that's not clear. How can I say whether we use the JPA from J2E versus whatever comes with Hibernate?
Not like this. What would you like to be able to do?
No. I guess my question is, how do I know if I'm using the JPA from J2E versus?
Oh, you don't.
Equivalent of.
Well, you don't know, right? That's the whole thing, right? When we build a WAR from this POM, when we build a WAR, all that we know is that we're using JPA. We don't know who's providing it.
We don't.
Yeah.
Don't you want to know?
No, because it's just JPA. It's a common standard. So we could be using Hibernate. We could be using OpenJPA.
No, but my question is, like, if I'm setting this up, like project environment.
Oh, if you actually want to deploy it, you mean?
Yeah.
If you want to deploy it, that's when you would set up your Tomcat to have Hibernate and to have you'd probably set up your Tomcat with like Hibernate and EHCache and all these other different things, and Hibernate would talk to EHCache. But here, yeah, in the project build stuff, yeah, we want to keep our code independent of the providers. Right, and the only reason why I even mention Hibernate in the POM is so that we can run Jetty from Maven. Just to keep it simple for the training course. But yeah, it'll be totally separate otherwise.
Based on whatever I have set it up in Tomcat.
That's what it'll end up using. Yeah.
What's a JALBox?
com.jalbox is the unfortunate sounding domain or group ID for this for the BoneCP connection pool. Yeah, it sounds like English, but I don't want to believe that it's anything related to that. This sounds like Martian to me. I don't know. Okay, so that's the POM. So the POM just says that we're going to be using Hibernate as our JPA provider, right? Let's see. Jetty env. So Jetty env didn't change, right? We're still just specifying our training database. WebXML is now referring to, or actually, sorry, let me get back to WebXML. I'll talk about that one last. The most important one is persistence.xml, which is under this meta-inf folder. This meta-inf folder gets copied into our jar, or our WAR. Okay. Persistence.xml declares basically what our JPA stuff is going to look like. So it says there's something called a persistence unit, which is basically like sort of an alias for a database, right? A persistence unit called training. It's going to be Hibernate's provider, right? Hibernate is going to be the provider here. And this, by the way, so this is the only place in our code, in our var, where we actually specify what the JPA provider needs to be. This is the only, so our Java code doesn't, again, it doesn't need to be tied to it. It's just our XML code. So
What is meant by JPA?
the Java Persistence API,
Oh, persistence.
yeah, or Java Persistence annotations.
So, this persistence unit name, that is the name of the database?
It's
Name training?
yeah, it's what we're calling the database.
Okay.
Yeah. So we're declaring.
So, does it mean that when it creates a database, it's going to use this name?
No, it's just the name that we'll reference from within our Java code. So it's declaring this name, and then when we want to create what's called an entity manager, we'll see in a few minutes. When we want to create an entity manager, the thing that manages, basically like our repository, the thing that manages entities in our database will say, hey, get an entity manager for the training persistence unit.
Okay.
So this is just giving a name, right? It says that we're using a non-JTA data source. So there's a lot of terminology flying around. And so before I talk about what a non-JTA data source is, probably the most important thing is remember this guy? Is JDBC/TrainingDB. This was that. This was our container managed database implementation, the thing that we had set up for JNDI. Right. So currently in our code, if we go back and look at our repositories, remember we're doing this data source, looking it up in our JNDI context like this. Well, this is basically doing the same thing. It's saying that Hibernate is going to manage this actual database.
Non-JTA means it's not a transaction based.
Yeah, so non-JTA means that it is not, that this particular data source doesn't support the Java transaction API. Meaning that it's a very simple sort of a data source. Transactions are going to become very important to us. Again, like I said, that was something that we saw in our pain points, and that's actually not a problem that we're solving yet. JTA is a whole nother thing, and we're not going to be looking at JTA in this course. To deal with transactions, we'll be using Spring.
Why do we have to specify here whether this data source is going to support it or not?
It just needs to know. Hibernate needs to know. I don't know.
So if it's not there, we can just leave it empty.
Well, you would still need. You could either say data source. I think the alternative is. Yeah, JTA data source. Yeah, that's the other option. Yeah, so it needs to know whether this thing supports standard like Java EE transactions or not. There are open source implementations of JTA. The one really popular one that seems to be out there is called Atomicos. It's a good name, but I've never used it. At any rate, we won't be covering that. Spring's transaction management is quite simple, so that's what we'll be using. And then we just need to populate a couple of properties here. So we're going to tell Hibernate to speak HSQL, right? And this is an important one. That I don't want you to have to look all this stuff up, so I'm just providing this. But this says that anytime we make changes to our entities, anything that would affect the schema of our database, this tells Hibernate to automatically go and update the schema.
Does it support schema versioning?
It does, although I think that's not automatic. There's some sort of a callback deal where you can do versioning as well. I've seen that done, but I actually don't remember exactly how it worked. Okay, so this basically declares all of our setup for this persistence unit, And then finally, in our web.xml, we just have to reference. We just have to declare that this training thing exists for us. So again, it's providing a name. It's making that name available. Seems a little bit redundant, but this is the way it's done. Okay. All right.
So if you go through the design view, does it make things simpler at the bottom?
Oh, no. This is just this. This is like your XML design.
Oh,
Yeah, unfortunately.
Essentially, you would have to use some sort of configuration guide to figure out what essentially you would
What's going on?
configure, right? At minimum.
I'm sorry?
I guess you would have to refer to some sort of configuration guide to have it.
Yeah, so here's the way that this always works. And this is going to be the truth of the matter here. Let's say that you weren't taking this course and you wanted to set up a new Hibernate project. How would you do it?
Copy paste.
You would copy paste from the internet. Yeah,
Based on there.
somewhere, some place on the internet.
Ah.
Yeah. Yeah, that's how it's done. I mean, it's really crappy, right?
So everything is done.
Yeah, I hope not. I mean, it's like the way that I always try to teach my courses, whenever possible, is sort of from first principles. Like I want you to be able to write all this code from scratch, and then any additional tools that you have are just kind of nice to have, right? I want you to be able to write as much of this from scratch as possible. Well, some of these things just no, you know. There's persistence XML, some of the stuff in web.xml that we'll see, and particularly when we get into Spring and we're setting up the application context, no, we're just going to copy paste that, right? That's why I've set this stuff up for you, is because I don't want this to be a copy paste exercise. Yeah. Yeah. So this is sort of the unfortunate thing about Java Enterprise application development, is there's a lot of copy and pasting XML involved. That's my big reservation about the whole deal. But that is what it is. Okay, so now that we've got, by the way, just in comment on time, we'll go for like 20 minutes and then break for lunch. Okay, is that cool? Are you guys dying or gonna survive? All right. Okay, so we've got our persistence XML. We've got all this Hibernate stuff set up. So the thing that we'd love to be able to do, the thing that basically so you know, let's go back to our pain points. Which, you know, kind of looking at our pain points and stuff, which was the most painful area of our code? Which code sucked the most?
SQL.
Repetitive.
Yeah, all the SQL stuff. Right. So we want to be able to basically delete most of that. I try to keep the API as similar as we can, and you know, of course, the way that I made sure that we designed our repositories was to attempt to not have to refactor too much stuff, because that can get confusing in class sometimes. But the implementation of our repositories, we want that to change. We want to basically rip out the whole details of our repositories and replace it with Hibernate, or JPA, I should say. Right. Okay, so the first thing that I want you guys to look at, and I'm going to give you some time to do this on your own, actually, is Google for something called Entity Manager. So open up, you know, if you Google for it, you'll find like the Java EE 5 and the Java EE 6 version. So click on 6, and just have a quick skim through Entity Manager. I'll give you guys a few minutes to look at that on your own, and then we can talk about it. Okay. Get this on recording, I guess. So again, this is a standard API, right? You notice that this is part of JavaX.persistence. right? This is not a Hibernate specific API. I'm not teaching you anything Hibernate specific here. We're using Hibernate as the JPA provider, but we're not using Hibernate's proprietary API. We're using the JPA standard.
So Hibernate Spring is different from the Hibernate JPA? Is there like a Spring version for the Hibernate?
Spring knows about Hibernate, but it's not. Leave Spring out of it for now.
So Hibernate came in before JPA, right?
Yes, I think.
So JPA was sort of inspired. The current version of JPA.
The current. Yeah, exactly. The current version of JPA is inspired.
Does Hibernate fully conform to it? There's more to Hibernate than JPA, or what's the relationship?
The simplest answer is that Hibernate conforms to JPA, but it also maintains its own legacy API as well,
okay.
which is different.
And we don't go into that.
And we're not going to. I mean, there's no reason to, basically.
So is the current version is a superset of JPA, or pretty much the same?
It's basically a superset, but it's not necessarily a useful superset. Yeah.
So would you say most people would stick to JPA?
At this point, in 2012, we should be using something else entirely. But at this point, people generally would just use standard JPA.
What do you think people should be using?
Scala.
Well, how does it address the database issue?
Oh, I mean, Scala. You would use an entirely different sort of DSL for dealing with database stuff. Yeah.
The other JPA providers are?
There's another one called OpenJPI that's pretty popular. I feel like there's one other, but I can't remember.
Eclipse Link? Is that the JPA provider?
Might be. I don't know.
So they all conform to one specification.
That
That specification is called?
JPA.
So, okay. So Hibernate conforms to JPA specification?
Correct. Yeah. In JPA, I should mention again, we haven't really talked about EJB, the Enterprise Java Beans. We mentioned it briefly yesterday. This idea that EJB came out and it was terrible and everybody hated it. So JPA, or so that Hibernate and Spring were a reaction to this. But JPA is actually part of the EJB umbrella. So it's technically it's EJB3 JPA, which is JSR 220. This whole like ridiculous Java enterprise ecosystem, which
So regardless of whether you use Spring or EJBs, your backend would be a common one. Conform to JPA.
It would be JPA. Yeah. So we're basically sort of cherry picking a little bit. Right, if we wanted to be fully EJB, we would be using EJB's current context dependency injection, something called CDI. Well, we're not using that, we're using Spring. We'd be using JPA, so we are using JPA, that's good. We'd also be using EJB's JTA, the transaction stuff. We're not using that, we're using Spring. Right, so we're cherry picking a bit.
Then that does mean that Spring has its own transaction management mechanism?
Yes, yeah.
How does it compare with DJB?
But with JTA, it's lighter weight. It's a bit easier to use. Yeah.
Isn't JTA the specification itself as to transactions should happen this way, and then there's different providers who build on top.
Yeah, similar. So this Atomicos thing that I mentioned is a JTA provider, and there's a few others as well. Typically, when you buy a license for like an enterprise Java servlet or an enterprise Java application server, it will have JTA built in. It'll have all this crazy stuff built in. So this is something that you would buy from Oracle, for example, right? That you would pay a lot of money for. Yeah. So we're keeping it simple. We're keeping it lightweight, and especially we're keeping it open source.
One
Using-
more question.
Yeah.
So, Spring's transaction management, do they conform to JT's spec?
No, no, totally unrelated. Yeah. Yeah, Spring has been quite happy to just sort of do its own thing, which I think is good. Yeah, so the Spring stuff is
I mean,
what
other
we're using.
than its lightweight, I mean, do you see, the major differences in terms of functionality or performance or?
I mean, it's just different. It's an entirely different technology. So that's hard to say. Okay, so let's talk about this entity manager, and then I guess, yeah, let's just talk about the entity manager, and then we'll go to lunch. So the entity manager is used to interact with this persistence context, right? So we set up our persistence context, meaning the database, right? So within a persistence context, you have a bunch of entities, right? So we actually have this concept of entities now. And these entities in their life cycle are managed. So the entity manager could be doing some clever stuff with caching, or what, we don't really know. But the idea is that at the end of the day, the objects that we have are these entities, and they should be in sync with the database that we have as well. Right. So the API is used to create and remove entity instances that are persisted in the DB, to find entities by their keys, and to query over entities in the database. So, what sort of things can we do? Well, probably the most sort of important obvious things would be like find, right? We want to be able to find an entity by its primary key. This is like API number one that I want to show you guys, right? Find. Some Java stuff, right? I know that some of you don't have as much exposure to Java, so let's. I just want to talk about this little bit of syntax. Again, hands up who's a little bit weaker on Java. One, yeah. So this is Java generics, right? An entity manager can manage any kind of entity, right? So our entities are going to be our addresses and our contacts and whatever else, right? And those have some particular type, right? We want to retain type safety. We don't want our entity manager to just be giving us a Java lang object, right? So these are declared as generic methods. We tell it what class type to be looking for, and we pass it a key. If we're doing find by key, right? The key could be an int, it could be a long, it could be a string. We don't even need to really care what the key type is. But the most important thing is that we get some generic, again, T for a generic type. That's what find will give us back. So we tell it what kind of class we want, and it'll give us instances of that class. If we tell it we're looking for addresses, it'll give us an address, right? And this is doing all of our marshalling and unmarshalling for us, right? Okay. So that's find. It's an important one. How about merge? This is kind of an important one. Merge the state of the given entity into the current persistence context. Which sounds a little abstract, right? You'd want this documentation to say something like, save this to the DB.
Oh, that's what it means.
Well, it's not exactly what it means. But it does mean that probably eventually will get saved, right? Merge, persist also, persist is another good one, right? Make an instance managed and persistent. You'd want this to say, save this to the DB immediately, right? Well, it doesn't actually save it to the DB immediately.
So if you do
Not
like
necessarily.
a merge and a flush, would it do it?
Probably.
Guarantee.
Yeah, so So this is a little bit interesting. We've said we've said that we're not using JTA transactions, but and this is a big but. But we still do need to get a transaction, even though it's not like a JTA transaction. The only time when merge and persist are actually written to the DB are when we commit the transaction, which sort of makes sense, right? So we're starting to see transactions, but they're like not real transactions, but they're transactions that we need anyway. And so it's sort of, this is a little bit clumsy in its own ways. Like I said, this is going to deal with some of our problems, but not necessarily all of them yet, right? So this API is a little bit weird. That's why I wanted to talk about it first. But anyway, let's take a quick look just to kind of give you a sense of what sort of work we're going to have to do. Take a quick look at our address repository, and figure out, you know, what kind of code in here are we going to need to keep, and what kind of code in here are we going to need to throw out or replace, and you know, how are we going to plan to implement these things, right? All right. How about the constructor? What does our constructor for address repository do? Just gets a data source. Do we need that? No, let's make a list. All right, here's our to-dos for the repository. So our constructor gets a data source. Are we going to be using data sources anymore? No, right? So delete constructor. Right. We do need an entity manager. So we'll need an entity manager somewhere, somehow, right? In terms of the code that's already there, we need to delete the constructor. All right, how about initialization? This stuff where we're setting up the table for our addresses.
That should be taken care of by the entity manager or something.
Yeah, it should be taken care of somehow.
Entities in the context.
Yeah, just the fact that we have an entity should be good enough. So we should be able to delete init. Right? Which also means that we get to delete our setup. Right, we won't need that anymore because Hibernate is taking care of that setup for us, right? Okay. Find. Okay, well we probably need find. Right, that's sort of an important part of the API, right? All right. What were some things that we didn't like about find? Yeah. Find. Well, basically delete everything, right? Like all this crap is bad, right? Like all of the try finally blocks. We're not going to need find to throw a SQL exception anymore, right? Hey, check it out. Find doesn't throw anything. Or it's not declared to throw anything, right? Of course it can throw something, but it's not a checked exception. Yeah. So we get to, you know, this is basically going to become a one-liner. It's just going to be entity manager.find, right? So that's going to be good. What else? Create. create and update. So those both could actually be one, right? If we look here at merge, let's look at merge. Well, all right. So unfortunately, the Java doc for some of this stuff is sort of slim. So I guess I'll just promise you that merge will be good enough. Persist isn't even going to actually be necessary for us. Right.
What's the difference between the two?
It's subtle. Talk about it later. You had a question?
Same question.
Oh, okay. Yeah. The answer is I'll tell you later. Maybe. Okay. So, create and update. Maybe those could just, become save. Right. So merge might be able to just do it for us, right? We'll try that. We'll see how it works. All right. What else? Delete. Oh, same deal with delete. Entity manager dot, what is it? Is it delete or remove? Remove. Right. So this is our to-do here. And then unmarshal we don't need anymore, right? Right. We won't need that. So our address. Oh wait. So that was for our address repository. There was one additional method that we had in the contact repository, right? Yeah, find all. So we'll deal with that a little bit later. That'll get us into talking a little bit about JPQL, the Java persistence query language. So we'll talk about that a little bit later. But that's going to be the basic summary of sort of the first chunk of work that we're going to do after lunch. Is we're going to try to replace all this stuff with entity manager code. Okay. We'll also see what we mean by entities, right? We've talked about the entity manager, but we haven't talked about entities and what entities look like, right? We said in our list of requirements here, we said that the objects themselves should determine the database schema. So we haven't seen how that looks yet. And I know, so some of you guys have worked with Hibernate before, so you've seen the annotations that you would use. But so we'll talk about that after lunch as well. Sound like a plan? All right, guys. It's 1:45. So let's start back up at 1:45. Okay.